Okay, right. So let me try to explain to you some of the very basics in mathematics, especially in co-math. These are very basic stuff, but they're very important because you will find these things throughout the course. When I'm saying through the course means AS and A2. Quite important stuff during AS and A2. A2, yeah. Right. So let's see what are these basic things are. There are a few basics actually, many basics if you will, but we are discussing here some of the very important facets of it. One of them is factorizing. I would say factorizing is a very important, basic, essential. We should know very well. Factorization. I think that's how you write it. Factorization. Why this is very important? Factorization is important at least in these areas, at least. Okay, it can be used in many areas. These are the main areas. I think one of the areas we can use factorization just to simplify an expression, just to simplify something, to simplify an expression. Quite important. To simplify an expression. And also we can use factorization to solve equations. And also it can be very handy when you are drawing curves, sketching graphs, basically. Sketching graphs. These are the main three areas I would say factorization is very important. So let's see how to factorize. Before we go into factorization, let me explain to you the basics of the basics of factorization. Now, for an example, let's say there's a number. Let's take a number like number 12. This number 12 can be written as always using two of its factors. For example, we can write this one as 2 times 6. See? Or even you can just write this one, rewrite this one in this format. 2, 6. In mathematics, we know this means 2 times 6. So basically what we did here, we have used two of the factors. See, two of the factors and times them together to rewrite that. So these are called factors. 2 is a factor, 6 is a factor. And if you note this one a bit carefully, if you divide 12 by 2, you're going to get 6. You see, in a similar fashion, if you divide 12 by 6, you're going to get 2. That's the nature of all the factors. Let's look at another. You can write many factors here because it's a number basically. We can write, for an example, 3 times 4. You can write it like this, or you can write 3, 4. These are factors. So basically, we have factorized 12, 2 and 6. So 2 times 6. This is a very basic. This is a very basis of putting into brackets. At school they would say we're going to put something into brackets. That's why they're saying putting into brackets, because we are just using two expressions. When you times them together, you get the parent function, parent expression. The original expression, if you will. In a similar fashion, we can say any of them, like 18 for an example. We can write 6 times 3. See? Or you can say 6, 3. Cool? You can write any number of them like this. 2 times 9. So forth. In a similar vein, you can actually use something like a different one, like x. Let's say xy. Actually, in a sense, it's been already factorized, but you can also factorize this one if you want. You can just, theoretically speaking, if you want, you can write this one x times y. Isn't it? Like that. So that's the whole idea in factorizing. We are trying to put into brackets. Put into brackets means we're trying to find factors when they times them together to give the parent expression or the number or whatever. So let's see the methods of factorization. There are a few methods of factorization. Okay, number one, let me explain to you number one method. I would say finding a common factor. Finding a common factor, if there is a common factor. Finding a common factor. A common factor. Now, unlike numbers in here, in this syllabus, if not in this context, we are not really dealing with simple things like numbers. We are dealing with expressions called algebraic expressions, as you know already. For an example, let's say we have an expression like 2x plus 8. We can factorize this one. So the way we are factorizing this one is this. This is how we're going to do it. We can look into a common factor here. For an example, I can rewrite this one as 2 times x plus, possibly I can write this one as 2 times 4. Now it's very clear that 2 is a common factor. Right, 2 is a common factor. So I can take that 2 outside, like that. And if I take 2 outside, what I'm going to get here, x, and plus, so it's also gone, so what I'm going to get is 4. So there you go. That's factorized. So we can say that 2 and x plus 4 are factors. If you want, you can even put a bracket here, but normally because this is just a number, so we don't really have to put a bracket. If you want, you can put a bracket here as well. Let's look into another one. Let's say we got 3x plus 9. The common factor is 3, isn't it? Because 3 goes into 3x, 3 goes into 9. When I'm saying goes into means 3, we can use 3 to divide 3x. We can use again 3 to divide 9. So that's the common factor. So I'm going to take 3 out. So what I'm going to get here, x plus 9 divided by 3 is 3. So that's a factorized. Okay. Let me do a few more. Say we have 4x plus 16. We can clearly see that 4 goes into both, so we can take 4 out, x plus 4. And we can justify this. Our answers are right. Because see, 4 times x, 4x, 4 times 4 is 16. 2 times x, 2x, 2 times 4 is 8. 3 times x is 3x, 3 times x is 3x, 3 times 3 is 9. See, you should be able to work backwards and justify yourself. You did it right. You don't have to do it always, but at the start, at the beginning, I would say do that. Number 3, number 4. For an example, there's another one, slightly different one. Let's say we have something like xy plus y squared x. We can clearly see x goes into both. Because we can divide both by x, so x can be taken out. And if y goes into both, take y out as well. So when you take an xy out, sometimes students tend to think there's nothing there, but there is 1 there. Because see, because 1 times xy. What you did here basically, xy divided by xy, so you're going to get 1. Same as before. So you got 1 here, 1 plus x is taken, and one of the y's is taken because y squared divided by y will be y. And again, you can justify yourself, xy times 1 is xy, xy times y is y squared x. So these are basically the very first method called, what you call the common factor method, factorizing using common factor. Right, for an example, let's look into another. Let's see whether, let's say we have xy plus 5. Can we factorize this? Can you factorize it? Well, we can't factorize it because why? There are no common factors. Now somebody can argue, yes, 1 is a common factor. Yes, of course 1 is a common factor. You can say that for any of them. If you want, you can just write as, for fun, 1 times xy plus 5. Same thing. Basically what we're saying, there's nothing to factorize here because y is in the fully factorized form. Because no common factors there. Okay, no common factors. So when you're factorizing, if you think of factorizing something, the very first thing you should look for whether there is a common factor or not. It's very useful. Let me do a slightly different version of it. Let's say we have a question like this. A question like this. What do you think? Can we factorize this? Think about it a bit. So, we can see whether there's a common factor. We have 4 terms here. 1, 2, 3, 4. 4 terms. But if you look into 4 terms, there are no common factors across the board, isn't it? For an example, you've got AC, AD. There is a common factor A here. But compared to these things, they have YC and YD. So you don't really have A is not a common factor, C is not a common factor everywhere, D is not a common factor. When I'm saying common factor, you can't find same letter everywhere, isn't it? So there are no common factors for all of them. But maybe there are common factors partially. For an example, there's a common factor here, and there's a common factor here. So probably we can just try it, just factorizing partially each one, and see what we're going to get. So let's say the common factor A here, what are you going to get here? C minus D. What's the common factor here? Is Y. What are you going to get now? C minus D. There you go. So that's a little bit tidy now, isn't it? Now if you look carefully, you can see C minus D is a common factor. For both. For this one and this one, C minus D has become a common factor. Then what we can do actually, we can take C minus D out. Take C minus D from both of them. See, as secondary factorization. I've taken C minus D from there, I'm going to get 1 there now. I mean A basically. C minus D is gone, I got A. Taken C minus D from there, I'm going to get Y. There you go. That's fully factorized. If you want, you can justify this one by expanding the brackets. If you expand these brackets, you should get that. C times A, AC or CA. C times Y, CY. You see that. D times A, minus D times A, minus DA you got there. Minus D times Y, minus YD. It's there. So, you can justify yourself that you did the right thing. So that's the very first thing you should look into in the factorizing common factor method. If there's a common factor, you may take it out. Right, so let's see a few more, 1 or 2. Let's say we got this, what we got. 5a squared plus 10b. Now, 5a squared plus 10b, what could be a common factor? What is a common factor? What do you think the common factor would be? Your 5 is a common factor, isn't it? Because the letters aren't common at all. So 5 is a common factor, take it out. What you're going to get here is a squared plus 2b. That's it. 5a squared divided by 5, you got a squared. 10b divided by 5, 2b. Right, that's basically it. Number 5, look at this. Let's say 25 x squared. I don't know, 25x squared. Let's say 8x squared plus 2x. Say 16x, sorry. 16x. Now, x is a common factor, obviously, it's very clear. And so somebody might say now, 2 is a common factor. For an example, yes, it is true. Let's say we taken 2x out. Okay, now I'm just trying to show you like a common mistake. Sometimes we do. Now x is a common factor, that's fine. Now somebody can think 2 is a common factor, which is very true. 2 is a common factor. So they're going to carry on factorizing now. So 4 divided by 2 will be 4. So you're going to get 4x here because yx is taken, 1x is taken. Plus 16 divided by 2 will be 8. The 8 and x is taken. So they might give the answer like this. Now this answer, it is right, but it's not complete. It's not complete. The reason is this: when you're factorizing, you should take the biggest factor out. The biggest factor out. So it is not complete. So what's the biggest factor would be here? 8x, not 2x. Okay, so I would say when you're finding the common factor, take the biggest possible one. So then the answer would be, a better answer would be, if you will, taking 8x out, what are you going to get? X plus 2. That's a complete answer. You know? Or another person can take it from there. For example, they can take 4 out and you're going to get exactly again same answer. Then become 4 times 2 is 8 and so forth. But I would say take the biggest common factor out. Okay, so rather than just doing partially. Well, doing partially at least something. It's doing nothing, obviously. Right? But when you take common factor, take the biggest common factor out. Okay, finding. So I would like to amend this one, even saying finding the biggest common factor, if you will. Finding the biggest common factor, if you will. You know, the biggest, the greatest. The greatest common factor, if you will. Alright, so let me give you a question. Try this one in your own free time. Or, you know, after watching this. 3a squared b plus 9b squared a. Try this one yourself. That's it. Try these two questions. Alright, I think that's enough for the time being for the first method. Let me do a few more clips for you guys for the other methods and other stuff. Alright, so it's enough for the time being.